This is Unit 8, Chapter 8, Lesson 3, Composite Figures. Here's Mr. Romanovich, everyone's favorite.
This is the most serious video that we will do all year. I cannot stress enough the enormity with which you should take this and the weight on your shoulders to be successful with this video, because Mrs. Benoit told me that's the case. We're going to find the area of composite figures, or shapes, and by the end of this, guess what? You're going to be able to find the area of composite shapes. Something like that, where it's not one specific shape. So this is neither square, nor rectangle, nor circle, nor parallelogram, nor triangle, nor trapezoid. It is a combination of those things. So we'll be able to find the area of that. What is a composite shape? Well, it's shapes made up of, or composed, get it? Composite, composed of other shapes. Shapes like this. Crayon, ice cream cone, my condo building. So in these, what we're going to do is then we're going to decompose them into shapes that we can figure out what they are. Then find the area of each and add them together. Or, in the case of probably this one, we could find the area of the empty space and subtract it from the whole. Here's our first example. So we're going to do this a little differently now. So instead of you doing all this number calculation and me doing that too while you sit here and watch me punch a calculator, I'm going to do it a little faster. So here's our shape, and as we look at our shape, what we see here is we have a semicircle, which you now know is a half of a circle. It's not part, it's not a quarter, it's not a third. A semicircle is always a half, and it's connected to this other shape here. So the first thing we need to do is we need to divide it into two shapes. And what I'm going to do is I'm just going to put a dotted line across here. And what that does, it creates this semicircle and it creates this rectangle. And then we know the formulas for each, and then we apply the formulas with the dimensions that we have. So here I have the area of the semicircle. What I know is the distance from here to here is 7 inches, because 1 inch is here. What I need for the area of a semicircle, I need 1/2 pi r squared, right? Because it's half of a circle. Then I need to find the area of my rectangle. So the area of my rectangle is base times height. So that after I punch my numbers in, the area of my rectangle is 8 times 2, which would give me 16. Then the area of my semicircle, I take the radius. If I know this is 7, that's the diameter. That means that this, the radius here, yoink, is 3.5. So I have 3.5 inches squared times pi divided by 2. And what I do is I find this and this. So I find this area here. I find the area of this shape, and then the area of this shape, dot, 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 and then I add them together for the sum. Did I do that right?
Yes.
Okay. Now we have this dealio. A couple ways you can do this. One is you could start by dividing it into a trapezoid and a rectangle, or and then we do our trapezoid formula, and then our rectangle formula, and then add them together. Or what we can do is we can find the size of the whole piece and then subtract the missing piece. So if we extend this into a rectangle, then we use our rectangle formula, base times height. Then we need to find this triangle, 1/2 base times height. Or for those of you who prefer base times height divided by 2. Then, yoink, we punch in our numbers. Here we know our base times height is 12 millimeters, that's the full length of that side, multiplied by the full length of this side, which is 10 millimeters, giving us the area of the rectangle. Then we need to find this. Now here's where the logic comes in. If I know this distance is 7, the remaining distance here to get us to 12 would be 5 millimeters. if I know this distance is 10, the remaining distance here to get us to 10 millimeters is 4 millimeters. So 6 plus 4 is the same as 10. 5 plus 7 is the same as 12. Now we have a base and a height of our triangle. So down here, the area of our triangle is 1/2 5 times 4. And in my mind, I'd take half of 4, which is 2, and multiply it by 5. Yeah! Now we're looking for the difference here of this thinger. So we have this rectangle in the middle of a circle. And what we want to try to find is what's the area that's outside of the rectangle. It would be shaded if I could shade it, but I don't have my shader marker anymore. So what we need to do is we need to find the area of the circle and then take away or like cut out that piece of the rectangle. So we know area of the circle is pi r squared. The area of a rectangle is base times height. So what that gives us is, since we know the diameter is 10, we only need the radius. Half of the diameter is the radius. That gives us 5. So the area of the whole circle is pi times 5 squared. So that's about 75 if you're going to ballpark it. And then the area of the rectangle is base times height, 2 times 3, and that's like 6. And since we're taking this out of it, we take the area of the circle and remove the piece from the middle. So we'd find the difference then, not the sum. We find the difference, and then that way we'd know what was remaining to find out the area of what was remaining. Or remaining, or remaining, or I'll repeat remaining again. Here's our target. That's fast, right? So you're going to have to rewatch this probably like 5 times. Can you hit the target? Here we go. We've got this shape down here. It looks like, as I'm starting to look at it, I see what shape is this? What shape is this? Figure out what your formulas are. You have area of what looks like a semicircle, which we know what that is. And then we have area of a rectangle. You're going to find the two, and then the question is, will you add them together or subtract them? If you have any questions, please rewatch this video or ask me or ask Mrs. Benoit, or come to Learning Lab and ask somebody else so that they can be confused. Please make sure to reference the video as many times as possible. What time is it, Miss Benoit?
The end.
It's the end. Thank you.